Welcome to New Frontiers in Space Exploration. I'm Ed Hoffman, PMI Strategic Advisor, and as you can see, I'm wearing my former NASA uniform, and I can still fit in it. I'm here with Amanda Mitskevich and Greg Robinson, both of NASA, to discuss the challenges, changes, and innovations in an increasingly dynamic and invigorated age of space exploration. So let me start by introducing our panel. Amanda Mitskevich is the program manager of the Launch Services Program at NASA's John F. Kennedy Space Center in Florida, where she is responsible for overseeing NASA's provision and management of domestic commercial launch services for robotic missions. She ensures overall mission success through leading, managing, and directing the progress of planning and acquisition of launch services, commercial launch vehicle engineering and analysis, mission integration, launch vehicle production, launch site processing, launch campaigns, and the actual launch. Amanda has received numerous achievement and performance honors throughout her career, including NASA's Outstanding Leadership Medal and the Distinguished Service Medal. So thank you, Amanda, for joining us.
Sure, I'm glad to be here.
Absolutely. And let me also introduce Greg Robinson, who's the Program Director of the James Webb Space Telescope. Greg's focus is development, efficiency, management processes, contractor performance, and mission success. Formerly the NASA Science Mission Directorate Deputy Associate Administrator for Programs, he has worked to ensure high performance during development and operations of 114 science flight projects. Greg serves as faculty at the Columbia University School of Professional Studies, where he teaches leadership of complex programs. He's received numerous achievement honors, including the Presidential Distinguished Executive Rank Award. Greg, thank you for joining us.
Glad to be here. Thanks, Ed.
So space exploration is undergoing dynamic change, representing both challenge and opportunity, more distribution of teams, remote work, increasing digital technologies, and of course, global collaboration. Let's start our panel by showing a short video that captures the excitement of Space Exploration 2020.
This is all about perseverance, and doing it now is more persevering than ever before.
And liftoff as the countdown to Mars continues.
You know, this has been years in the making, getting us to where we are right now.
And liftoff of the Falcon 9 rocket and Cargo Dragon spacecraft.
Of tracking the movement of water across our planet.
An incredible time for NASA, the space program. Once again, launching U.S. crews from Florida.
Liftoff of the Falcon 9 and Crew Dragon. Godspeed, spot and dog.
We're behind you, Mom and Dad.
It's a cool video. It always is exciting to see launch and these systems taking off. It's clearly an exciting time for NASA and space exploration, as the video demonstrates. Amanda, can you share some of what we saw in the video and some of the exciting missions that NASA has and is leading today?
Sure. You know, so every time I watch that video, I've seen it a few times since we put it together. It almost chokes me up to see Bob and Doug go to the space station and embrace their counterparts at the space station. So that's what you're seeing at the end of the video with all the excitement. We have had a lot going on this year, and the video that you saw is really just since March. So in the time frame that you saw, the first part of the video, I could talk for like an hour on this video, so I'll try to keep it short and have some good points in there. But there's a lot of exciting launches that have happened in just that short amount of time. One of them is, of course, I'm wearing my Mars 2020 shirt. Mars Perseverance launched in July 30th. And that was a huge mission for the agency. You know, we are going back to the moon and onto Mars. And this giant rover is headed towards the red planet now. It will arrive on February 18th. And some of the things that it will be doing is checking the environment for eventual human presence there, even collecting samples. So you saw in the video, you saw the rover in its processing facility, and you also saw the helicopter. So this will be the first time that we have had a helicopter on another planet. And that will fly shortly after the lander checks itself out in February. Probably what you also noticed in the video is everybody's wearing masks. It was a very complicated time to put a mission this huge together in the middle of a pandemic. And you saw our administrator talking about that and how we persevered through this. So we did encounter a lot of challenges along the way. A Mars mission has to launch in a planetary window, and that is usually only 21 days. We lost 10 days of that window early on in the processing due to several challenges. So we were attempting to add window days at the end of the window. Fortunately, we were able to have everything to come together. It's really, NASA has a really great team. It's really impressive how everybody pulls together from all across the country and really all across the world to make missions like this succeed. And so we did launch on time, and it's on its way. And then as you go through the video, there's other missions, very important, that happened. You saw the crew demo. That is the first crew launch that we have had from American soil since 2011 when the shuttle stopped flying. So extremely exciting for the whole agency, the whole country. Just amazing to see that happen. And it happened on a launch vehicle that was developed by a commercial company and a crew capsule developed by a commercial company. So NASA is headed in directions of more commercial involvement in space, less government-owned hardware, more partnering with the commercial industry to make things happen. You also saw in the video some missions that are coming up. The next one is the Crew 1 mission that follows the demo. That will be coming up in November. So we'll be taking more crew members to the International Space Station. You also saw Sentinel-6, Mike Freilich. That's a huge mission, a partnership with a European Space Agency, EUMETSAT, CNES, NASA, and NOAA to study the ocean surface level rises. Very important to understanding our planet. A great partnership that NASA has had with the European Space Agency for a long time. That will be launching out of Vandenberg Air Force Base, also on a Falcon launch vehicle. And so we have also embedded in the middle of that video, you will have seen some hardware, bigger rocket bodies coming in to the Kennedy Space Center. This is the government-owned rocket called the Space Launch System that is getting ready for launch next year. The government is still owning some hardware and developing it so that we can get places that no other rockets can get to. And that is part of our new Artemis program, which is the Moon to Mars effort. So we will be going back to the moon. Really, it's about getting there, staying there, and getting back. Before it was just getting there and getting back. But now we have to figure out how to stay somewhere for a longer period of time. It has to be more sustainable so that we can learn to go onto Mars. And that's what the Artemis program will be about. And I think we ended the video with the great scene of Bob and Doug entering the International Space Station and all the excitement that was around it. So really, in this short amount of time, it has been tremendously busy for NASA and exciting. Yeah,
the images are always amazing, and it is very emotional. I think, like you say, Amanda. I guess someone had once said, "A good picture is worth 1,000 words." I think when it comes to NASA and space exploration, a good image is worth probably 100,000 words. And I can imagine you can talk for an hour, but then we wouldn't hear from Greg Robinson.
That's right.
So we're going to turn it over to Greg, and also we're going to start with a short video clip of, I believe, the James Webb Space Telescope. So why don't we show that clip, and then we'll come back with Greg.
This is your telescope, an engineering marvel, an exploration powerhouse. Use it to look back in time and explore the first galaxies that formed after the Big Bang. To peer into atmospheres of planets orbiting the stars. It's your eyepiece to the uncharted, unknown, and unimagined. This is the largest, most complex, and challenging space telescope ever constructed. It will change our understanding of the universe and our place in it. The James Webb Space Telescope. Equipped with the largest primary mirror ever to be flown in space, at 6.5 meters, it's more than 6 times the size of the Hubble Space Telescope primary mirror. Webb's 4 cutting-edge infrared instruments and cameras operate at super cold temperatures. Temperatures colder than the surface of Pluto. Getting this cold is done with the help of the largest sun shield ever flown, a 5-layer, tennis court-sized sun shield that blocks heat from the sun, Earth, and moon. Webb will be the first telescope to detect light from the most distant galaxies in the universe. These first galaxies formed about 13.5 billion years ago, only 300 or so million years after the Big Bang. Webb carries advanced technologies to tackle some of the most fundamental questions about the universe. How did the first galaxies form and evolve? Are there chemical signatures of the building blocks of life on other worlds? Is our solar system unique? Launching such a large telescope into space is an
incredible image to watch what's taking place and the development. And what can you tell us beyond what we've seen about the James Webb Space Telescope, its purpose, and the key challenges you're dealing with?
Well, first, Ed, I could certainly listen to Amanda talk about this for an hour. So even two, quite exciting. So certainly glad to hear that. So James Webb is a huge astrophysics telescope. It's the follow-on to Hubble. And I think most people have heard about Hubble. It's been around for more than 30 years. Thanks to many service missions by Space Shuttle before it retired in 2011. So James Webb will actually peer back into the universe, looking back, searching for what we call first light. and that's a few hundred million years after the Big Bang. If you could imagine hundreds of millions of years in space is still short when you're thinking of billions of years. So we're hoping to see the early formation of the universe, of new galaxies and old galaxies. We will also look at better characterize our own universe, our own solar system, better characterize planets for habitability. So James Webb is much larger than Hubble. It has infrared capability that allows it to see through smoke and clouds and dust and all of the gook of space. So it can actually look back much further than Hubble. So Hubble certainly has given us amazing, amazing new science. And we often say Webb will actually rewrite the textbooks, the physics books, because we will learn things that certainly we've never known before, and probably for a long time. So in order to put these big telescopes into space, we have to find ways to build them because they're so huge, they won't fit inside of a fairing, of a rocket fairing, as Amanda mentioned. We have to find ways to build them so we can fold them up, in this case, origami style, and you heard some of that in the video. And then, of course, it has to deploy in space, which really keeps you on pins and needles until that actually happens. So Webb will be folded up that way. It will actually deploy in space, multiple deployments. You saw the huge sun shield there. That's the size of a tennis court. That was a brand new technology, 5 membrane layers. And a couple of fun facts. Hubble, of course, operates in what we call low Earth orbit, 350 or so miles above Earth, which allowed us to service it with the shuttle. Webb would be 1 million miles out at what we call Lagrange point 2. And these Lagrange points, there are 5 of them around and within our area. And that allows for stability. You don't have to use fuel to keep your altitude. So Lagrange point 2 is 1 million miles out. It's also on the far side of the Earth, and you look like a straight line through the Earth. You have the moon and you have the sun, all of those on a straight line. And what's important about that, in addition to the stable orbit, and the sun shield, it actually blocks the light and the heat from the moon and the Earth and the sun, because you want that big telescope actually peering off into dark space without that additional heat. I compare it to me learning how to hit a golf ball. For some reason, I still can't track unless I put my shades on, because that background light just confuses me. It never goes straight, by the way. So that sun shield really helps with that. It also helps with, on the telescope side of the observatory, we're operating at 370 degrees Fahrenheit below zero, quite cold. On the other side, we're operating at just under the boiling point of water, about 180 degrees. So an amazing, amazing technology in addition to the telescope itself and the scientific instruments. And lastly, this is a huge partnership with our European Space Agency international partner, ESA, and CSA, the Canadian Space Agency. And the other last piece, one of ESA's contributions is the launch vehicle. So we're actually launching on an Ariane 5 rocket, which is non-US. That's a little unprecedented. And we're launching from their launch site in French Guiana in South America. And that's about a year from now. Thanks.
Yeah, it is truly amazing because I think when you speak to most people, they naturally think of NASA in terms of the human exploration. And yet I know I have a lot of family members and friends who tell me they think the Hubble Space Telescope was the coolest, most amazing mission because how it's changed totally science. And James Webb goes beyond that. So there's more pressure, but there's more opportunity there, right? And that's partly what we're talking about here at the PMI Brightline Strategy at Work event. We're talking to leaders from all over the world, all different industries. And this session is on leadership for space exploration with a focus on the future of work. And I want to get to some questions in terms of how do you work with these teams to make these amazing things happen? We're living in a world where work is done through increasingly complex projects. There's more pressure, I know, on expectations for cost, for getting things done faster, for being able to be innovative. Always the most important factor is people. the capability of people to work together across all these different lines through a culture of collaboration and constant learning. And there are many factors involved in achieving this kind of complex mission success. The people, the inclusion, diversity, the appreciation for the team, how you maintain that, build that, particularly in a remote time. How do you create that sense of belonging? Global collaboration. Both of you have mentioned the partnerships with different international colleagues and obviously with industry. And the notion of dynamic learning. That when I was there at NASA, we could develop something. I had to do a training course that would last for 5-10 years. By the time I was leaving, the course was always dated before you released it. So this constant knowledge swirl that's taking place. And all of this you have to do with changes in robotics, AI, automation, and probably the demands for doing it faster and cheaper, while also making sure that it's successful. So with that as a background, talking to leaders, let me continue with you, Greg. What are the driving factors that are redefining the way NASA has to do its work and will be doing the work in the future?
So Ed, one of the things on James Webb I mentioned, there have been over 10,000 people to touch James Webb, engineers, technicians, hundreds of scientists from all over the world. And I mentioned ESA. Of course, as you know, ESA is made up of 22 member countries, plus other supporting countries. So a lot of countries, over 10,000 people. And that's with partnerships, NASA centers, prime contracts, and a whole host of subcontracts. In the US, Webb was developed in 29 different states. So someone has to integrate all of that stuff. So just an amazing, amazing scale when you think about that, in addition to getting this thing off the ground a year from now. So one of the things we look at is what we call, as senior executives, leading people, leading change, building coalitions. They sound so fundamental, but not always easy to do. And as you know, leading change is tough because we have traditional ways, quite effective, emerging methods coming along, as you mentioned earlier. And you have to find ways to bridge that gap because the old is good. There's a lot of reliability, a lot of lessons, a lot of knowledge there. And you have to bridge that knowledge with new knowledge and the ability to pivot when new things come along. So that's part of the challenge as a leader is bridging those two cultures of old and new. I don't mean age and old, but just knowledge and experience. So that's one of the challenges. Another challenge is the people. As you mentioned, the workforce changes rapidly. We often look at over 2 or 3 year period, a lot of these teams change by 20, 30, 40, 50%. That's a huge change. A lot of those are what we call early career, generally means younger. They bring new, bright ideas. I mean, many of the folks coming in now, all of these tools that we work with to communicate, they grew up playing with this as 3-year-olds. Actually, in my case, my grandsons as 2-year-olds. So they bring that knowledge to the workplace, and we have to find ways to take advantage of that. And that includes things like big data. I mean, the little ones use big data all the time, just in the way they work and play. And as you know, you remember we used to have still have some data archives. We've got a ton of data down from these satellites. So we have to archive them somewhere so that the scientists can go in there and pull this data out and actually create the science products. So now, instead of these huge buildings with huge tape drives, we have clouds. And those clouds are outside of government-owned domain. So we're learning ways to tap into that. We don't always create the data. We have data buys now, certainly with earth science. That's another way of peeking into the commercial world. Amanda mentioned many of the commercial partnerships. On the science side, most of our missions are actually competed through the scientific industry and academia. So we're doing a lot of this stuff now, and I see that trend actually accelerating in the future. And I have a dozen other areas I can talk about, but I'll stop for now.
Yeah. So the focus on, I think you've always been about this, you focus on the people. I think you used to explain to me, if you get the people right, they'll take care of all these other factors. You talk about, obviously, the advent of big data. When I was at NASA, I was doing small data, talking to people and getting answers that way. Now the knowledge is available through so many incredible systems and ways of doing analysis. Let's shift over, Amanda. You've been, I think, throughout your whole career at the Kennedy Space Center, involved in launch. What could be cooler than that? One of the things that I always loved going to Kennedy, because people always treated me nicer than really any other center. And someone explained to me that at Kennedy on any given day, you have a large part of the people there who are international partners. And since I left, the growth of the industry, SpaceX, Blue Origin, so you have this whole community, right, that you need to come together to work so that these images that we see are cool and successful. As a follow-up to what we spoke about with Greg, what do you see as the capabilities and skills that are most important, and what are the changes that have the greatest consequence maybe for NASA and for launch? What are the things that stand out that you're dealing with today in terms of the greatest challenges and issues that in terms of the work?
Yeah, that's a great question. The times have really been changing rapidly. So I say that, but then let me take you back to the late 80s. That is a time that NASA went to buy commercial launch vehicles rather than having government-owned hardware. It's a big difference in terms of how much involvement the government has and how much things cost. So going commercially is more reasonable, and you don't have to have as much government oversight of the process. So in the late 80s, we started putting our precious science satellites on top of these commercial launch vehicles. And now as you fast forward to current and what you saw in the video with Falcon 9 launching the crew to the International Space Station, you see that there are, the commercial model has been also embraced by human spaceflight now. And so what we're seeing is that has really energized the launch vehicle market that we work with. So we have many, many launch vehicle providers that are just excited about launching people and excited about going back to the moon and excited about helping NASA go to Mars. And so what we're doing really is we're fusing some of the heritage launch providers with the new launch providers to get a workforce that understands how to work in those environments. And it's more than just understanding the technical skills that you need to get to these places that are so difficult to get to. It's not like jumping in your car and driving across country. There's all kinds of things that you need to worry about as you're going to these other places. And so bringing those cultures together, I think, is really helping NASA move forward in its thinking. The heritage companies are really, really good at doing what they do successfully, getting science missions to orbit safely and humans to orbit safely. And now these new companies are coming in. They do things a lot different than the heritage companies, but it works. And it's working in a new model. And so we, as a government organization, really need to embrace those things that are happening and be flexible and accept the changes so that we become a better learning organization as well. So I think it's really a critical time in the industry where all of these new companies are coming in, and it will give us a really good jumping off point to do some of the things that we want to do in the future.
Yeah, it also, it also sounds like a place where innovation is able to be achieved because you have experience, we know is part of this. And so you have this experience, but then you also have new ideas and new possibilities intermingling. And so it's a framework, and obviously that's partly the reason for that innovation, new ideas, and with the approach for being successful.
Yep, I think that innovation is definitely critical, and it certainly happens when you have new ideas that are coming into the mix now. And
one of the things, I'm sure there are many people watching who would love to work at NASA or in space exploration in any part of it. So it gets to the area of capabilities and skills, what they are, what you think is most important. Let me start again with Greg. What do you think are the prime capabilities or skills, Greg, that someone who wants to be involved in aerospace, whether it's NASA on the government side or industry? What are those capabilities most needed for leadership today and moving forward in the future?
So I would say number one is I always say most people work for NASA and in this business already very domain smart. They know their technical areas very well. So I see that as a given. Then those leadership skills that we often talk about, being able to work within teams, being able to lead teams. And sometimes, as we know, leading is the ability to follow and participate. So I think that's number one. Number two, I would say being able to actually build a team and create collaborations, even beyond your team with partners in industry, partners internationally, extremely important. I was talking to someone this morning and I talked about building relationships was one of the most important things. So you can always pick up the phone and call someone. I do that with Amanda a lot. And with others, some of my international partners, I think that's just critical. So building that relationship. So if you have to have that bad call, it's an easy call to make versus the first time you make a contact. Also, the ability to mentor and grow your workforce. I think you need to develop, encourage training. A lot of times the training is across the organization, but allow time for people to take good training, particularly the soft or power skills, depending on your background, to learn how to work with people. I think that's extremely important. And don't be afraid to change. Change is normal, it's natural, whether you want it or not. COVID can tell us some of that, larger than we ever expected. Change is good. You pick up new ideas, you learn from others. And as you know, in NASA, we do a lot of rotations, what we call details, people to other centers. We've tried to do some of that exchange with industry and with DOD. It's a little bit harder for all of the general counsel rules. But we try to do all of that because you actually go out and you share your current knowledge with others that helps them improve, and you bring back other skills. We do rotations on review teams. Again, it's not the technical knowledge we're trying to grow, it's really the personal knowledge, those skills of working on a team, being able to challenge someone else on their product because you've been challenged on yours. So you know how to receive it now on your next development. So those are some of the areas, those soft skills, leading a team, collaborating, and building relationships.
And I'll ask the same thing for you, Amanda. If I were 30 years younger and I want to work for you at Launch Services, what are the capabilities and skills that you're looking for? And are you able to get it at this point in time with all the changes going on?
Yeah, so ditto to what Greg said, just to start with that. In NASA, everybody is tied somehow to the mission. And that really seems to have just an incredible way of bringing a team together in itself. And I think you have to keep creating that environment to make sure people feel connected to what that mission is in order to have people feel part of it and feel committed to it and stay, especially in an environment when you have new businesses in the aerospace industry coming about. You want to keep those employees that are so talented and so connected to the mission. One of the things that we have been doing recently in the program that I manage is we've been trying to hire new folks. Like you said, it can be a challenge, but I tell you, with the NASA symbolism, people still flock to get jobs with NASA. We don't pay like private industry pays, but the mission is unbelievable. I probably should mention, and Greg knows this, NASA ranks #1 in large government agencies in the employee viewpoint survey. So every year the government goes out, it does a survey of all the employees that work in the government. Every year NASA ranks #1. So the connection to the mission is really critical in making people feel happy. So let me go back to what we're doing in our organization. What we've seen, I think, is the age gap is pretty large for people that are in leadership positions now and people that are getting hired on, because NASA goes through these waves of hiring. I got hired, not to date myself too far back, but I got hired after the Challenger accident. And since then, there's been small pockets of hiring, but we really need to be hiring a lot more people, because people like me, people like Greg will eventually need to retire. And as we bring these people in, we want to make sure that we can teach them the things that we think have helped us along the way. And so what we do in my program is we do have like a strategic offsite every 18 months, not a cliche offsite, but it's an offsite where we actually get together, we plan for the next set of years, put a tactical plan together. The important part of that, though, is that we also bring 5 to 6 younger folks into that mix so that they can see how management is doing these preparations. And one of the things that came out of this a couple years ago was that the employees needed to feel more connection to how the program was moving forward. And they wanted to know what we knew. So they took the initiative to stand up something we call the Launch Services Program University. And they own and operate this program where the managers teach courses, they tell employees, give them on-the-job training, do all kinds of things that help prepare employees for being the future of the program. And it's really done a great job of connecting all the disciplines within the program. So you mentioned, you talked about engineers, scientists, that's your typical NASA person, right? But actually within NASA, there are accountants, there are procurement people, there are public affairs people, there are all kinds of folks that are participating in making sure we get our mission done. And so we were finding in our program that each end of the building might not have been talking to each other. And this integrated people better to make sure they had the skills to be able to move into leadership positions within the program. So that's just one example of how we're trying to put some knowledge into the new folks, bring new folks in, put some knowledge into the new folks to help them operate on a day-to-day basis, connect them also to the strategy that we have so that they can do their own decision-making, and then deploy them into great jobs.
So it's about the mission. Everyone always at NASA talks about the mission. That's the one thing that brings people coming together, creates that sense of purpose, the engagement. And when people see it, they want to be a part of that. And then it's, I guess, the collaboration, the constant learning, and the respect for the colleagues you have inside and outside your organization.
That's a great summary.
So you, a final couple of questions I have to ask you. So by the way, I was there before Challenger, so that's how far back that goes. Both of you have been around a long time, and I know you both love, you love what you do. You're always, not always, but you're smiling in terms of talking about things. What is it that excites you now in terms of NASA, that after all these years keeps you wanting to work there and to do the things you're doing? What's your excitement coming from?
You want me to start?
Yeah, sure.
Great. Sorry. Okay. So, yes. So first of all, you're right. I think I have the best job in NASA. I get to see just about every science mission that NASA is working on in some form or fashion, either getting them a launch vehicle or advising them on a launch vehicle that they might be buying. We're working with Greg even on James Webb Space Telescope to help him understand the Ariane rocket. So I think the thing that really energizes me are seeing these missions launch, hearing about the science, seeing the industry change and being part of that change, and trying to maneuver an organization that's a government organization into understanding where that is, how we fit in, and how we still can provide a valuable service to the agency. It is, you saw the launches in the video, but to actually see the launch itself in person is incredible. So everybody should take that opportunity. And I try to see every launch, whether it's a NASA launch or an Air Force launch or a commercial launch, because every one of them is extremely exciting.
Yeah, no, it's, I remember my times there. I think I remember first seeing, then feeling, and then hearing everything. It's totally multi-sensory and very emotional. And I think it captures, that excitement you're talking about. Greg, what about you? What keeps you excited and wanting to show up every day?
So I certainly echo everything Amanda just said. From the launch side, I've seen many in my career as well. And the butterflies are always there, whether it's one of my missions or not. There's just something about it. So I certainly also encourage everyone who can go there be there for launch. Very important. So we see the hardware develop. We launch these things. On the science side, the most exciting piece is when we get scientific data back, whether it's what's going on with our own planet, with our Earth science missions, better understanding how the sun works and the impact the sun has on us here on Earth, with our heliophysics and other missions. And as we talk about things like James Webb, some of these big themes, the questions we're trying to answer with astrophysics is where did we come from? And are we alone? So we're trying to answer some of those questions. We get bits and pieces of data to help us try to understand those things. And of course, Mars is special, right? We talk about going to the moon. We have robots on Mars today. We have missions there. And the mission that Amanda just referenced, Mars 2020 Perseverance, launched this year in July. It's going to land in February and start picking up Martian samples, putting it in tubes, and either land those tubes on the surface or keeping them inside the rover for a Mars sample return mission, which is already in formulation. And hopefully that'll get launched in 2026. So that mission will go to Mars and land, pick up these samples. There are a whole lot of in-between parts of this mission, but I'll make it really simple. And put those samples back into orbit and blast them back to the Earth. And just think of all of the information we will get from these samples that help us answer the question, is there water, was there water, which is fundamental to life? And are there organisms, biosignatures that let us know that maybe life is or was on Mars? Just phenomenal science information when you think about it. So from a science standpoint, we're learning new things all the time about other worlds and our own planet. So that really excites me. So I can tell you the excitement from 30 years ago to now, it hasn't changed at all. And as Amanda mentioned earlier, the shift with a lot more commercial, a lot more international. There are countries around the world who didn't even think about exploration and science 30 years ago, actually doing it. I mean, on the African continent and South America, just all over the world. So that really excites me.
Hey, I thought of one other one, Ed, that I know Greg will resonate with. So the other thing I think that probably keeps us both at NASA is really the people, the team that is built. Even in the environment where we are right now, where we're all virtual, the strength of the relationships that he mentioned earlier that have been put in place are still there, and they help us every day. And I think keeping that team and I want to say in a family atmosphere, but not family really, but you can tell that every employee cares about each other and they care about making the mission successful. I think that is something that is difficult to create and difficult to find. And so that's a really big part of NASA and how we put our teams together.
Yeah, I think that's a great way to close this. Unfortunately, I'm getting signs that we're at our time frame. I've often heard people say people show up at NASA for the mission, which is amazing, but they stay for the people. And I think that's what both of you are talking about. I want to thank Amanda Mitskevich and Greg Robinson for the time here and for what you do for the space program around the world. And again, thank you for your time, and hopefully you had a good time. We can do this again sometime.
Thank you, Ed. It was a pleasure.
Thank you.